in this room, and I don't know whether you have been checking Erik Thorstensson, how he has been preparing some material. I don't know if we will ask us to work or put us to work or not, but I am very intrigued. And I think that his work is very much in line with the title of this conference, Learn by Doing, Prototyping. I guess that you have already read Erik's resume, and I would say that, in short, he is the epitome of ability, social ability, creativity, and how to solve problems. I think this is very much in line with leadership, in doing, building, to make schools. Welcome, Erik.
Hola. Yo hablo un poquito español, pero no.
I speak a little bit of English, but I'm not fluent.
And as slow as possible. I heard there might be some translation for the people who need it, so that's going to be exciting to see if they say the same things. Because just like De Bono was talking about, I work a lot with humor, and we'll see how word jokes or puns translate. You never know. They might just end up here. Today is going to be, it's a workshop, so this is actually the perfect crowd, so we can just lock the doors. So we don't, because there's going to be some hands-on things today, because it would be strange to talk about prototyping without actually having to prototype something. Don't you think? Yes. Yeah, that would be really strange. So now half of this workshop is going to be me playing on stage a little bit, so you can see that, because the key to this workshop is play, and the engagement and the activation of your mind that comes through play, and prototyping and making something and then making it different and seeing what it is. So a little, very tiny background. Everybody always says a tiny background. I was going to keep it super short. I don't know if I can, but I'm from Sweden, a mechanical engineer, and I read the book about lateral thinking. So I didn't know that De Bono was going to be here. My teacher gave it to me, and since then I never worked at a company. I just skipped out, started my own business, and have been doing product development for myself for 7 or 8 years. Traveling around, because for me, making and prototyping has been very natural. I don't know why exactly. We're trying to look into that, but we should have a science research team seeing why I like doing what I do. So, today it's going to be about Strawbees, because that's our latest project. It's one thing that just popped out of my mind when we were in India. So I was at a visit in India, showing recycling machines that we had invented. So it's a troclador, a die cutter, roller die cutter, very simple machine, and we designed lots of things for these simple machines. So tiny little pieces, so you can make objects from, for example, plastic bottles, food packaging, cardboard. That's one of my favorite prototyping materials, cardboard paper. Everybody automatically jumps to rapid prototyping through 3D printing. But that's one of your tool sets. We use 3D printing too, but that's not the key. The key is learning how to explore many different ideas and getting people comfortable in that. So that's what it's going to be today. What they cut out, these things out of our roller die cutter, and I've chosen not to show any pictures today because it's going to be trying to describe this. Now you have to use your imagination, your thinking skills to abstract this. So you take a plastic container for food or something, you cut it open so it can go through 2 little rollers, and then you just roll it through and out comes some kind of shape. Okay? Okay? Yes! Wow! Why? Why? Something like that. I don't. Why? What's there's something like? Yeah, doesn't matter. So something comes out, and what we did first was a clothespin, and I'm going to show you now because this is a show and tell. and workshop. So usually I have a piece of plastic. I actually don't have a piece of plastic on stage. So today a piece of cardboard will have to be a piece of plastic. So now use your imagination again. This is plastic, okay? Everybody, plastic? Yes. What color is it? Blue. It's blue plastic. So I take this piece of blue plastic and I cut out a thing here. First I just wanted it to be a strange shape. So what is this? Yeah, that's right. It's not something in particular, but it is blue plastic, the material. So this is our clothespin. We designed a clothespin. So this is a small piece of blue plastic, this big. This is this big, okay? Can you tweak that too in your mind? Fantastic. We have some really good minds out here now. So, and then you cut a hole in your blue plastic. I'm going to show you like this. Sorry for standing with my back, but I think it's better. See that? Yes. What is this? Blue plastic? It can be a monster. But what it is, it's a clothespin. So we made a clothespin to make from waste plastic. So I'm going to fold this a little bit more like origami. It's a kind of different material to play with. This plastic is very strange. So now we have it. And I need something to hang. So I'm going to use this clothesline here. You see the clothesline? And we'll take this wet t-shirt here that we have to dry. I'll put this, oh, it's already hanging there. It's a really good clothesline. Then we take our clothespin, because it's going to be windy out today, squeeze it over, it pops up and locks it. Yeah? Hey! And how did we design this? You saw some of the features. This is a very strange thing. Where do you think it could have come from? How did I come up with this? This is like, it has a strange little secret to it. Do you want to discuss it for 30 seconds between yourselves? Very shortly? 30 seconds. Anybody have an idea? It seems like you have lots of ideas. Anybody wants to throw themselves out the cliff and answer? No. It's actually.
I think you looked at flying butterflies, and it sort of landed on the clothesline, and then.
That could have been it. That could have been. That's a very viable answer. Once again, that's all these things because it looks like butterflies when we put them on the clothesline. And you can make any kind of shape, actually. So when we have classrooms we teach kids how to make this clothespin instead of buying it, because it works actually really well, and you can just use your scissors. So as you see, scissors is a great prototyping tool. But basically, we were just having fun. This is where humor comes into this, because we were making monsters that could hold our business cards. Completely stupid. Not a good idea, but it was fun. And we were making this. We had eyes on here, and it started chewing. Like, rah, 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 rah. So we call it monster mimicry. Do you know about biomimicry? When you're imitating nature? So we're imitating our imagination to make something that could bite. And then we looked at this strange thing that we made and saw that actually this solves this problem. That's the value creation Demona was talking about before. Like, you look at something strange that you might not have developed with a certain intent, but what value can this fill? And that's an incredibly great experiment to have. So the first time they make this, just ask the kids, what is this? And then there's going to be tons of different things, and they're going to use it. So, but our idea was, this is a clothespin. So we gave them the machine. We donated a big machine. Like it's not an expensive machine. It's the 350 euros. But it works forever. It's like lifetime warranty. And the machine, you just put in different little tools. So they got the machine plus 2,000 of these pre-cut clothespins. what do you think happened? Now this is a hard time. Imagine something, or fake. Fake a story, what happened? So now we have another 30 seconds. What happened when they got the clothespin? This is hard. This is hard for imagination, trying to, but if you make up a good story, that's great. It might be the truth. 30 seconds of thinking what happened when we gave 2,000 of these to the kids in India.
Can you tell people when asking to use the microphone, because otherwise the people that is translating cannot hear and cannot translate.
Okay, but we don't need to have, yeah. Okay, yeah.
I'll take it.
This is really tricky. But I think we've been at the conference for thinking, so I think you've been doing all these twisting and turning and trying out these things before, so I'd just like to try out you as a crowd. And there's no evaluation of this. This is just a fun way of starting your minds. So does anybody have a good story of what happened? Anybody wants to share? It's no problem. It's basically for you to talk.
They start clipping them to each other.
So
Did they start attaching them to each other and making sculptures or making new shapes? Or?
Exactly. To this day, they have never used them as clothespins. Because somebody already gave them clothespins. Somebody had a budget for clothespins for the school. Somewhere there was a budget for that. So that was completely ridiculous. But what they didn't have was construction toys. So they were just building these massive sculptures, like huge things, lots of colors. And like we came in like the second day after they had been just left with this. So that once again says that you don't have to define the value of things all the time in the beginning. But that gave me an idea. I want to make a construction toy that can do this for any kind of social background, anywhere. You can just put these machines in, recycle materials, and start building and exploring. Because our brain gets so active when you're building in 3 dimensions. It just, something happens. I don't know exactly. Neuroscience is a very tricky field. The more we learn, the less we know. Very bad for science. It's interesting. So we don't know exactly what happens, but we know a lot of things fire up in the brain. So if you look at your brain when you're working in 3 dimensions, it just starts up. So I wanted to develop something, and this is the problem. When you have a set goal, you get cramped. I didn't know what to do. I didn't know how to develop this toy, this construction thing. But I was working with a lot of different projects, and I was traveling around, but I knew what I wanted to solve. I had a couple of limitations for my construction toy. It was supposed to be able to connect cardboard, because that's easily available. It was supposed to be able to connect drinking straws, because they had tons of those like lying around in the streets everywhere. So we wanted a standard thing that was available everywhere, low cost. So those are the 2 things, actually. Basically only this. And then somebody asked me that already had the machine if we couldn't build some polyhedra. You know what a polyhedra is? The cube, the tetrahedron, all these geometrical shapes. And when you look at those, though, they have special kind of connections. So 3 legs, 5 legs. The Platonic solids are a very nice little mathematical exercise that we actually do now. So that was what I wanted to do for the drinking straws. So we can make them from waste and make polyhedra. So when you design a thing like that in the computer, you follow? So when you sit down with your computer and draw this, you draw the first leg first. And that's where I stopped. So I just, this is interesting. Let's just print this out. So I had my machine close, which is important. The maker movement now is making this accessible for everybody. You have super fast access to try out an idea before it's even finished, which is the essence of prototyping. Let's just see what happens. And then this thing came out. Really tiny. Do you see? I usually have a big scaled up version, but I actually forgot that. But you're going to see this up close later. It's a very small thing. I can walk around like this. You see here? Yes. The thing. Look. You see? Tiny little thing. 1 leg of a vertex in a polyhedron. I'm going to run to the other side too. This is really good for my brain, so now I'm going to give a better talk, because you activate your brain by running around too. Here it is. Strawbee. Yeah, tiny. Don't feel left out. Here it is. You too. Okay, running back. So this was supposed to be able to go on top of the straw, like that, slide along, but also go into the straw, like this. And this isn't super fancy. Just a little bit heavier straw. You take a second straw. Wow. This is where it starts to happen. Woo! You have all these wonderful, yeah, really great. But then the same piece, again, does this. You hear that snapping sound? That's advanced engineering. To get those dimensions in a flat piece of plastic, it's trial and error for a long time. But now we have a mechanical straw. Wow! Now it's happening, yes! Thank you! So this is the basis. You can just add more of these pieces, more and more, and build any kind of connection that you want to have. So if you're looking at something in 3D, for example, computer graphics use vectors all the way. Every time they build with the little triangles. So you can just add more and more legs, like this. Now it's still mechanical. But if you want to, for example, build a tree and understand how a tree, the mathematics of a tree, for example, the best way to learn about that is to actually start building it, copying it, and looking at it, because you look at it in a completely different way than if you just look at it passively and, okay, how does a tree... Because when you don't have to build it, you don't really need to look at it. You kind of look at it briefly. But for example here, the tree splits up in two pieces, and they go in different directions, like this. And now you want to lock this piece. You just fold over the same little piece over itself, and now you have a locked tree that keeps those angles. And then you go about measuring the legs, like these, the branch, it's this long, then you cut it to that length, a scale of the branch, for example. Add another connection, and usually, how many branches go out? There are actually different trees. How many branches go out? How do they split? Several? Yeah. Can be lots of things, but very usually there's only one point where they only split up in two. And then a couple of centimeters further, you have another split of two. So you just continue adding like this. And then if you wanted to make it stand, you can ask the students, like, how do we make it stand? And you start out with the technical construction things. You start like, okay, we have to build a base. No, how does the tree do this? We have to look at how the tree actually solves this problem. It has a root system under a wide area of something heavy, dirt. So then we build that. We fake it with books and paper and just put out a root system from here. So this is just one of these examples of exercises there where all the kids build. They can build and copy and understand. So in this case, copying, it's not anything creative. But this gives the base for being creative because you learn how to use and construct with this. And also, you know, it's a little bit of maths, but it's much more fun maths. You can actually look at all these angles, what angles are usual in this, and just draw conclusions from that. So yeah, here's our tree. Wow. Did you follow the root system? I have to build it somewhere here. Or maybe this is the tree. Doesn't matter. Switch perspectives and see which tree you like best. So this is a toy to teach making through this creative play and understanding through playing. Because the first thing you need to get your students really into this is the engagement, the motivation. And these things, they can actually set their own goals. We have very limited, like instructions don't tell you exactly what to do. And now I'm going to show you one thing. You don't need the Strawbees to build this. I'm going to show you one of our favorite instructions this far. It's a biometric instruction. So we use our hands, our arms, our legs, our feet. In this case, I'm going to show you the shoe meringue. It's a very recent biometric design. So you take a piece of cardboard. Now it's not plastic, okay? Not plastic, this is cardboard. And different thicknesses are very fantastic to experiment with, so give the class different thicknesses so you can draw conclusions from this. This is the thing. We want, if there are 30 kids in the classroom, or 30 grown-ups in a board of directors or something like that, you want 30 different models, because then it's real science. Then you can look at it, draw conclusions, see what works, see what doesn't. Not only have 30 models where 50% work, 50% are just failures. Even though failures are okay, it's harder to learn something from it. If you see an array of solutions, and 75% of them work and 25 work, we don't know why, we can look at those and have them as part of the result of the scientific research we did together and think about that. So now I'm going to show you the shoe meringue. This is an experiment you can do at home. And what you need is, you don't actually need, you need some kind of pen. But if you use Strawbees, you need a pencil because it's really good. You need a pair of scissors. And you need a piece of cardboard, a little bit bigger than this, because this is just going to be for 1 foot. And then you take, if you're right-handed, you take your left foot, like this, and you draw. Now you can hear I'm drawing here. Because the microphone isn't down there. I'm not that limber. I'm pretty good, but... So here's my foot, and draw along the lines of the cardboard. You see that? Because that makes them strong. This is also great if you don't tell them this beforehand. Some of them get weak, and then you can discuss that because the failures are interesting. Why didn't this work? So you discuss that and make them comfortable in having things that don't really work. Because you, as a classroom, you're doing the research. It's not the individuals. We're a collective, we're like a human species. We should do this way with all our research. So it's okay, we can draw conclusions from everything around us. And then, obviously, it's easy to tweak it so it works. So if you really failed with one of your feet, you can just make a new one, because cardboard is very easy to find. If you need some hints, you can email me, and I will tip you on where you can find this. So at a conference like this, I think it's good for thinking. I love to make, so I think let's make on stage. Now you saw me cut this foot, yes? My left foot, and I have pre-cut 2 other left feet. I have 2 left feet here. So I'm going to stumble around this, might really be bad. And I've been talking so much about this, the failing. And you know, our brain is hardwired to learn through stumbling, falling, drawing conclusions, experiencing. We do that for the first 5 years really intensely, and that's part of our way of understanding and learning fast. And then we kind of stop. So that's why we love these things. So I'm not going to be afraid of failing today. So now I've put this up like this, and you see my feet look like some kind of propeller. So then I take this pencil, and now the magic happens. We use pencils because they're hard, they're wood, they're strong. And I poke a hole in the middle. Watch my fingers in the back. Motor skills, important. So I have this here. It's already fun. Something that spins. So be playful with this. You can actually stop your workshops a couple of times when you do these things. Because now you have the gyroscopic effect. You can feel it. You see, when I spin this, I could actually, now you have to get it to stick, but I felt the gyro forces. It wanted to keep still. And that's part of this project. So now I have this hole. I take my Strawbees in this case, but if you have tape or glue, you can use tape or glue before you get your Strawbees if you don't want them. So I take 1, 2, 3 Strawbees, and now we're going to show you the secret of prototyping in cardboard. So I take these tiny little things again. And this time, instead of stopping here, I take it all the way to the bottom like this. Does everybody see in the back? It's very small, but you're going to see this later because we're going to start playing soon. So I take this all the way. This is going to be used as a washer. I squeeze this through. the cardboard here. And then this time I used a 3, but you don't need anything like this. But this is only to give you a better appreciation of the angle that you need. So they're spread evenly. You follow this far? You don't really need the language for this. That's the best part about show and tell. We were in China and this translation system failed completely. And I was just like... And that works really well. So maybe I should do that more here too. You see, angle. And now we want to lock this angle, because if we start throwing this, it's going to spin. So then they learned this. We need to have some way of getting these to stick. So we need 2 points. So I make a second hole. Like this. And then I squeeze one of these legs through there. Now we have it locked. And how many of you have degrees in aerodynamics? No one. That's great. Because it's a really advanced field. And it's really hard. And it's one of those areas where we actually don't know exactly what's happening still to this day. Which is why these experiments, when the kids make them, and if you have 30 different versions, we can actually draw real scientific conclusions from these experiments. So for you to remember this, you're going to fold the toes up. Or if you're right-handed, you have your left foot here facing upwards, fold the toes upwards towards you, and fold this part, the trailing edge of the wing, downwards. Like this, and like that, like this, and like that. Now we have it on all 3. And this is the failure part. Let's see what happens. Yeah. Thank you very much. So don't be afraid. In this case, it could have gone wrong because I don't know, but I know these are very, very... One more time. So this is the part where cardboard comes in as the fascinating material. Look, I love cardboard. You can see it visually. Cardboard is great because you can do so many modifications to this. Now I had a very tight circle. Did you see that? So I modified this by decreasing the lift. And now we're gambling again. Nobody knows. Let's see if it comes back this time. Yeah, a much longer flight path. And it's when you do these things that you learn how this works. You talk about it, you experience it. If I throw it this way, I'm generating lift. What happens? It's going to go upwards and go down. So what it does, the boomerang goes and lifts through the curve. And that's the way you learn these things. And another thing, now we create value in this, because what's a boomerang's value? Does anybody know the value of a boomerang? They come back. It's like your frisbee with yourself. So there's a lot of stories about the Aboriginals having this as hunting weapons, but this is a show-off thing. They never hunted with boomerangs. They made versions of boomerangs that just hit things hard, but they were supposed to go fast and very easy to describe the flight path. This was just for fun. So they started out as fun, but now we'll take this part again, modifying the value of this, because the Strawbees makes it possible to fold them over like this, and when we're in a city like Bilbao with nice weather, it's wonderful to have a little fan. So these are the things we want to teach, to inspire, because it's easy to modify. You don't glue it, you don't set it so it's stuck. You can modify it as many times as you like. And that's part of the kind of it's not by design, it's by accident from my part. But when I see it afterwards, the after construction this is what I wanted to achieve. You follow? So we do lots of these experiments. Soon we're going to be able to play. I'm sorry for this long talk again. Is it okay? Are you still with me? Yeah. Fantastic. So let's go over here. I love aerodynamics, and some of you saw that I want to teach both language and history and aerodynamics, for example. So this is a mix of mathematics. These are the tetrahedron we were talking about before. And this is a fractal tetrahedron. So we group the kids up to make one tetrahedron each and combine their tetras into this fractal structure. And then you have a really magnificent kite. So I'm running to create the wind. But these fly incredibly well. And the best part is, so you have a classroom and you make these. Then you group up the groups, again, 4 and 4, and combine your kites. And you build a bigger kite. So then you have 4 of these, so it's this big. And if you have even more, you make this big kite. And the only thing you need to get is get it up into the air. The rest is going to solve by the wind, if you have wind enough. So it's amazing to have these. They set up those goals themselves. They just start, can we make it bigger? Yes. It's when they ask those questions and want to do something, they're just going to go on forever. It's going to be hard to stop it. So now I don't have this sound here. That's too bad. Oh, I might have it. Because when we want to end our workshops, we say, well, we set the final goal. And then I put on an how do you say it? An illusion for your ears. Because everybody's seen all these illusions for your eyes. Have you seen all these things when the things start moving, but it's just a flat drawing? Have you heard the shepherd note? Do you know about that? It's a note that feels like it always just rises and rises and rises. And it's in a game of Super Mario Brothers from the 90s, late 90s. There's this sequence where he's running up a staircase. And I play this at the end of these to talk about the science behind this, how our brain interprets this sound and doesn't understand how to interpret it. Let's see if we can. You want to hear it? So is it okay if I Google it here? This is exciting. Now you can talk between yourselves a little bit about, now you've seen some of these things. What would you like to build while I find this? Okay, talk with each other. What would you like to build after this? Does the sound work here? Can I connect to that? Do you know? No, there's nobody in there. I can just use this. Oh, it's connected. Let's use it. Very stressful. And then the parents come in because they want them to come so we can go home. And they're hearing this crazy, and the kids are like, we just have to finish the final Sierpinski tetrahedron. Wait a second. So this is how we finish it off. And then we talk about the science behind this. Because this is a very interesting, you hear it, it's very strange. And it actually goes in the other direction if you want to too. That's one of the craziest ends of a workshop you can have. And they will never forget that. They're going to talk about Sierpinski tetrahedrons, fractals, and shepherd tones for a couple of hours, and the parents, you're going to hear this all the time. It's a wonderful experience. I can actually take a shepherd note that goes downwards so you can get calm again after I stressed you up here. So remember this, shepherd, like leopard and sheepard. Shepherd tone, sinking, descending, there we have one. Oh, now we're landing again. We put this in an installation in a toilet when you're sitting down and everything. Whoa. Nobody wanted to leave. And then we put lights in it that were rising. Yeah. That's a side note. Thank you for bearing with me. So now we've gone for, let's see where we are in time, because now it's time for the workshop. We only have, this is time for hacking this entire experience here. Because now you are a pretty big group, and the first challenge now within this room is to split you in two groups. How do we do that? Anybody has a solution? Yeah, that's good. English speaking, how many English speaking do we have? And how many Spanish? Yeah, okay, so let's do that. Let's take English speaking going over to that side of the room. Okay, because now you're going to try this. And by the way, I just wanted, sorry, I was going to show one more thing before, but you can split up. I'm not going to show it. So English speaking and English speaking there, Spanish speaking here. And we want it to be two even groups. So, because I want you to be able to build a little bit. And if we, so, yeah, this is a little bit more Spanish, yeah? Anybody who speaks Spanish that can speak, you need to switch over. If you can kind of speak English, go there. But it's, that's where you are, yeah. I just wanted to show this. It's just the time flies so fast. We had so much fun already, but this is the thing. Sharing is wonderful. So sharing your experience here. So during a couple of talks yesterday that were magnificent, to activate my brain, I always draw and build. And I think there was one talk that was actually there about, like, feel free to build. So this is one of my notations. You can see there are some straight lines. And you sat next to me, and they were wondering, what are you doing? And I said, I'm making something. Don't know, think I'm making a wing. And in the second talk, I built it. So this is built in approximately 1 hour. This is an example of a design that it can go really fast once you're used to this. So now, this actually had a little bit of problems yesterday. And this actually is a robot, if I want to. So I'm going to turn on the lights here. But that's going to just, yeah. This is our robotics kit. So it's a battery-powered thing, but now it's just gliding. So I built it, and then I covered it with plastic bag, of course, as you do when you build gliders. And let's see if it flies. It's a little bit, you see, it's so lightweight. Let's fly it outwards. But this is the part of, just like with the boomerang, we want to teach this, for example, having this, building an instruction that's based on your arm. This is my fist up here, my foot there, and my arm here. So when the students make these, there's going to be lots of different designs. So instead of having one thing where they fail, once again, you make lots of these, and let's see if this glides. And then these parts here are tweakable, so you can learn how to morph your wing. So if it turns one direction, you take that down. You know, you can just learn about how wings actually work. This is also biomimicry. Let's see. Whoa! Best flight this far. And that entire thing, you can hold on to that for a while. So, wonderful. We are a little bit crowded on this side, so you're going to have a harder challenge. But maybe you're more fluent in the language out there, because now we're going to do, or maybe I can make an extra for some of you. We're going to do one of the exercises that we do. So now you're going to learn, like I've been talking about this thing. And of course, it's fun to play with it. So let's go out there. I prepared 2 positions. So I'm going to give you the rules now. There are 2 positions. And we talk about people who don't need to be managed. So this is for the Spanish team. So this is the workshop material for you. And this is the material for the English-speaking team. It's the same amount. You're going to have to fight hard or just switch over, because you actually don't need much language skills. Because the key to solving this problem is in the name of the workshop we're at. And I do this workshop at consultancy firms all over the world. And I do this everywhere. I do this to kids, grown-ups, any age. So it's actually a trickier exercise than we'd ever imagine. So don't feel haunted. Just have fun now, because now it's important that you all have fun. Here's for you. I'm sorry for that. I was just walking. So that's for that group. And we're going to split you up outside. But feel free to move between them. It's not actually a real competition. It's just two solutions. But if you want to make it a competition, feel free. It's up to you. So what's out there, I just forgot, you can see here, mechanics. Forgot that part. Really fun. We usually tell kids, make 5 things that move. Not objects, like not a frog. Just make something that moves. Then afterwards, what can this be? But I just needed this one to define what's going to happen outside. So outside, there are 2, I'm going to show you these positions. There are 2 Strawbees hanging from the roof in the middle of the room. And you all have to build a structure together that is as wide as possible. That's the problem statement. It may not touch the ground. You may not hold it. You cannot build against anything else. You must not use the rope. You can only connect your structure to this one single Strawbee. Okay? Does it make sense? You're going to see it out there. So those are the only rules. Everything else you can use, you're only allowed to use the materials in there, in the bags, of course. That's another thing. And so now, I'm going to give you the first hint. We never give this hint because it's so short. You have very short time now. But the interesting part here is how you spend your time. Let's see what. So you have super short time. The shortest ever. We'll take 2 minutes recap at the end. So you have 12 minutes. For a workshop that we usually have an hour to do. But that's no problem. Just use that too. But I think it actually might be better. Because how do you congress with a group that's this big? How should you approach this problem? You have lots of material. The material is actually not the shortage. In this case, you only have 12 minutes. And I'm taking more minutes the more I speak now. So I have to, so okay, let's go out and build. And think, how do you do this? How do you prototype this? Remember the name. And then at 43, we look at them and then we run back.
From where?
Here's the thing.
Let's go. Oh, sorry. I'm gonna go play with these people. I can also give you a couple of hints. There's lots of interesting tricks. For this one. I won't tell you exactly, but you know. Yes. Interesting. This is that they can make themselves with just simple syringes. Really fun. And they start out with this. It has water inside, so it's hydraulic. Yeah, I'm only here to destroy your working part of the exercise. It's okay. It's a lot of fun. It's going to be tricky for
Hay que ir enganchando esto. Espérate. Hay que ir enganchando esto.
un par de pajitas, voy a ir haciendo aquí las conexiones.
Pero es que luego te las ves delante. Ah, pero esta es la botella. Puedes engancharlo.
¿Alguien tiene pajitas que me pida? Yeah, I'm gonna write it down on the. Yeah, we just came back to China, now we go to Singapore tomorrow. All right, that sounds good. I like it. I see what they're doing. Let's connect with that. That's nice. That looks good. Oh, that's smart.
Stop it dropping down, and it can just drop down.
I don't know what I think this is the best way to go.
Aquí a tu aire, que si quieres hacer solo 4 planos y descansar, me lo dices y luego les
Ay, perdón.
¿Ese es nuestro grupo? Es el mismo.
Ah, fíjate, pues vamos a ver.
Vamos a ir viendo.
No, vamos a hacerlo.
Sí, vaya volando. Lo has dicho, el secreto está en el tiempo. Si el tiempo se aprovecha, pues... Oh, este no sale.
¿Y en la comunicación?
Venga, aquí hay algo que se puede
Ahí,
ver
porque
por ahí.
si no se nos
Venga,
va a ir.
bueno.
Yo como inglés no sé, hago de chino, cómo hacer en el mundo.
Ah, bien.
¿Qué será
Sí, pero ¿qué están haciendo? Porque si no, vamos a estar ahí, la cosa es luego conectar. Bueno, pero son fáciles de conectar ahí.
Son fáciles, ¿no?
Conectan muy bien. Si no lo articulas, lo sujetas con otra. No te articula ahí.
Ah, perdona tú.
So is this strong enough to where it's falling?
But it's probably going to fall down, so
So maybe we can dejar el peso. Ponerlo aquí. Vale, sí.
yeah, maybe we should join
Ready?
Oh,
And the kids can try it. You know, you have this in different lengths. You know, with like 10 meters, and they stay across the classroom like this. And the most fun exercise is actually when you put it this way. They put 3 threads in it, and kids have to, you know, help each other to put it right, and then you go down, and they have to pick something up, and they put it somewhere else. You know, like a team building activity. It's so fun.
That's fun.
Yeah, it's amazing. But first you have to build it. First you have to use it.
También, ¿no?
Bueno, pues intentando sacar por todos.
No, es que las estamos intentando unir.
Yo voto porque la mitad no tiene que ver.
Yo lo dejo así. Es que como hay que hacer como se pasar al otro lado. Si tienes una de dos igual. Eso era yo, que no me acordaba cuando se quedaba. Pero esta no tiene sentido el que le pongas. No más que sí, porque es la que se va a